Hi guys, welcome to the Natural Language Processing lecture, also known as NLP. This is another very important area of machine learning and artificial intelligence. Many leading companies are looking for people who got expertise in NLP. In this lecture, we will discuss how to manipulate and analyze the language data, the concepts behind grouping the articles, legal documents, and news based on their relevance. We will also discuss how to store the language data in standard format and much more. There are several books and lots of material available on NLP on the web for free. You can always Google it. If you're working with NLP in Python, Natural Language Processing by Stephen, Evan, and Edward is a very good read. It is free on the provided link. The documentation on official website is always a great resource as well. So you can follow the documentation on nltk.org. Let's create a couple of situations where you want to use your skills in NLP. Suppose you are working with one of the biggest research publication organizations like Springer or Science Direct. They want you to group the research articles by the area of research. In another example, you are employed by a leading news agency like BBC or CNN, and your task is to group the news by their headlines or topics. In a third situation, consider you are a part of a big legal firm where you need to find out the relevant documents from thousands of pages. So, in all these situations, are you going to do this work manually? Are you going to find out a page from thousands of pages? This is not an easy task. So these and many other similar tasks are not trivial for human. This is where natural language processing can help when we are dealing with text data. Typically, by definition, NLP is an area of computer science and artificial intelligence concerned with the interactions between computers and human languages. In particular, how to program computers to fruitfully process large amounts of natural language data. For the mentioned tasks, we want to do the following steps. First, we compile the documents in some fashion. Then we get features from those documents. And then we compare their features for similarity. In a very simple example, where we have two documents with the following text, the document 1 with a single sentence, red tag, and document 2 with a single sentence, green tag. A simple way to featureize the text document is to do the word count. We can transform text into a vectorized word count. And in order to do this, we basically create a vector count for all the possible words in all the documents. What we do, we then count how many times those words appeared in each document. In the above example, we have three words, red, green, and tag. In our example, the featurization of each document, document 1 and document 2, based on the word count will be: for document 1, red tag, red green tag 101. For document 2, green tag, red green tag 011. So the red green tag implies that 101 means red appeared one time, green 0 time, and tag appeared for one time, and so on. So a document represented as a vector of word counts is called bag of words. Treating each document as a vector of features is useful because once we have a bag of vectors, we can perform mathematical operations on them. For example, we can compute cosine similarities using the equation below. We can also compute other similarity matrices in order to figure out how similar two text documents are to each other. So we have a bag of words. We can improve this by adjusting word counts based on their frequencies in the corpus. A corpus is actually a collection of written text or a group of all the documents. We can then use TF-IDF, which is term frequency and inverse document frequency, in order to do this process. So moving forward, it's important to understand what is term frequency and what is inverse document frequency. Let's define these two terms first. Term frequency measures how frequently a term occurs in a document. Term frequency depends upon the number of occurrences of term T in the document, small d here. This suggests how important the term is within that document. On the other hand, inverse document frequency measures the importance of the term in the corpus, in the group of all the documents, and is equal to the log of capital D, where capital D is the number of documents divided by the number of documents in the corpus where T terms appeared. So IDF actually diminishes the weight of the term that occurs very frequently in the corpus, and it increases the weight of the term that occurs rarely. Let's try to understand this with another example. Consider we have two documents, D1 and D2, with some terms and their frequencies as given in the table. Let's compute TF and IDF for the words this and example. Let's start with the word this. In the document 1, the frequency of this is 1, where the total number of words are 5. Then the term frequency for this in document D1 will be 1 over 5, which is equal to 0.2. In the document D2, the frequency of this is again 1, but the total number of words are 7. Hence, in D2, the term frequency for this is equal to 1 over 7, which is equal to 0.14. Notice that D2 has more words. The relative frequency of this is smaller for D2. Let's compute IDF for the word this in the corpus now. So the IDF is constant per corpus. In this case, for the word this, IDF is equal to log 2 over 2, which is equal to 0. So now we got the values for TF and IDF. We can compute TF-IDF simply by multiplying TF by IDF. So in this case, TF-IDF for both documents are zeros. Now this implies that the word this is not very informative, as it appears in all documents. On the other hand, if we consider the word example, the situation is interesting. It appeared 3 times, but only in document D2. Let's compute the term frequency for example in both documents D1 and D2. So for D1, we don't have term example in D1, then the term frequency will be 0. For D2, example has 3 term count, and then we got 0.429, as a term frequency for word example in document D2. Let's compute IDF for the term example, which is constant per corpus. The IDF for the term example is equal to log of 2 divided by 1, which is equal to 0.301. Note we are using base 10 logarithm here. Now we have TF and IDFs. We can simply input these values and find out the TF IDF for the word example in document D1 and D2. We see that TF IDF for example in D1 is 0, whereas TF IDF for the word example in D2 is 0.13. So this implies that example is an informative word in the corpus. And in this case, this is more relevant to the document D2. So I hope you got a very good understanding of natural language processing. You got an idea behind TF and IDF and how they are computed for each document, and how the term frequency and inverse document frequencies are important for any word in the corpus. So this was all about the theory lecture behind natural language processing. A good thing is to do some hands-on. Let's move on and learn with practical examples using Python. Note that the natural language processing is not the part of Scikit-learn. In order to do this, we need to install another additional library in Python, which deals with NLP. You need to go to the terminal or command line and install another package called NLTK. If you have an Anaconda distribution installed on your computer, you can use a command conda install NLTK. And if you are not using an Anaconda distribution, you can use pip command pip install NLTK to install this natural language processing library. I will see you in the next lecture with installed NLTK. Good luck.